Hello and welcome everyone to today's battery storage webinar. My name is Stephanie Cox, Director of Business Development for Enertus. Before we get started, just have a few quick logistics to cover. All attendees are muted. However, we'll have time for a Q&A session at the end of the presentation. So if you do have questions, feel free to type them in the chat box and we will try to address as many as we can at the end. We will also provide our contact information to get in touch with our team should we run out of time to address all the questions. The webinar is also being recorded and the recording will be available on our YouTube channel by the end of the week. Thank you very much. For those of you who are not familiar with Enertus A+, we are a global consulting, engineering, and quality control firm for renewable energy and storage projects. Enertus has been established for over 15 years and has provided services on more than 220 gigawatts of solar and 12 gigawatt hours of storage across 3,200 projects worldwide. We have global offices in the United States, Spain, the UK, Mexico, Central and South America, South Africa, China, and Australia. Last year, we were acquired by A+, one of the world's leading testing, inspection, and certification companies with over 23,000 employees across 70 countries. Together, our companies leverage technical expertise and shared knowledge across all energy sectors throughout the world. It's our mission to ensure maximum profitability for our customers and proper risk management for projects providing innovative services with high added value. And now it's my absolute pleasure to introduce our guest and moderator, Jeff Atkin. Jeff is a partner at Foley & Lardner, one of the leading energy law firms in the United States. Jeff founded Foley's solar energy team 17 years ago and currently co-chairs Foley's Global Energy Group. Jeff has worked on hundreds of solar and energy storage projects, and he is recognized as one of the leaders in our space. Thank you for joining us today, Jeff, and I'll hand it over to you.
Great. Thank you, Stephanie, and thank you, Enertus, for hosting this. As Stephanie mentioned, I'm Jeff Atkin. I'm a partner at Foley & Lardner. We're one of the oldest law firms in the United States at 180 years old and 25 offices across the country. I'm the co-chair of our 200-person energy team, and energy is one of the 4 key sectors that we as a firm focus on. So we have some pretty deep expertise and focus in this area. Like Enertus, we work with folks, sponsors, investors, banks, utilities, manufacturers, and other key energy players. I personally have worked Enertus now for over a decade and have seen their hard work and expertise up front. I see Iñaki on the call, and we were just chatting. It's hard to believe that it was over 8 years ago. We were locked in a conference room in Miami, hammering out the details of one of the largest solar projects in Latin America that was successfully built at that time. Enertus has valuable expertise. I've seen it up front, and it's across our space. This topic of battery storage has always been the holy grail of renewables, and we're at a point where there's trust in the technology and the cost makes economical sense. And as a result, we're seeing battery storage deployed more and more. And I think with the new incentives like those under the Inflation Reduction Act, we're to continue to see this grow. So with that, it's my pleasure to introduce today's presenter, Matt Towery, Senior Manager at Enertus A+ Energy Storage. Matt has over a decade of experience in engineering, project management, and construction in renewable, fossil, and nuclear energy. Throughout his career, he oversaw development and pre-construction activities at a utility scale and battery storage developer, and he also led engineering capital deployment for regulated industries. Like Enertus, Matt's experience is deep and broad. We're going to learn from his experience as we navigate and deploy resiliency to the world's renewable energy infrastructure. Thank you again for taking the time to join us today. We hope you enjoy this webinar. Matt, with that, over to you.
Appreciate it, Jeff. Thanks, Stephanie, for the intro. Before we get started and walk through the agenda, wanted to take a quick safety moment. I think this is a pretty important piece when it comes to construction projects. The industry is moving fast. Schedules are becoming tighter. The risk of complacency comes into play as we go what I like to call autopilot mode during construction. Complacency can result in safety incidences. And while we cannot always control schedule due to weather, delivery delays at port, considering incorporating safety by design in your project should be something you should think about. Constructability is obviously a key element. You want to design something that you can actually build, but take into account listing points for major equipment, ergonomics during equipment installation. How are the men and women actually out in the field going to make this happen, from what you're designing on paper to the real world. So, the growth in renewables does not happen without the men and women out there building these projects. And a successful project, in our view, is when no one gets hurt. So moving to the agenda, we'll walk through 3 key phases of a battery storage project and touch on the Inflation Reduction Act kind of throughout the presentation. These 3 phases are the development phase, the pre-construction phase, and the construction and commissioning phase. And at the end, as Stephanie mentioned, we'll leave room for some Q&A. Feel free to ask questions on the Q&A log on the Zoom webinar, and we'll get to as many questions as possible. You'll see on this graph that where we have, as we're going to go through each phase, you'll see this repeated 2 more times. The x-axis represents schedule, from project initiation all the way to COD or commercial operation. And the y-axis represents degree of cost of change, stakeholder and stakeholder influence. It's a very, very simple chart, but I think it's something, previous life, we would bring this up at every meeting, whether it was quarterly or monthly during a project. And it's just a quick reminder of, hey, we're in the development phase, stakeholder influence is high, and the cost of change is low. So this is step 1 and the critical step for a project. So the first step in any storage project and solar project is to clearly identify the use case. This graphic from the Rocky Mountain Institute, who I believe they're just called RMI now, is a great picture of the various slices of the wheel or use cases for battery storage. The question we often get asked, right, is I have a solar plus storage project. What's better for economics, AC coupled or DC coupled? And there's no silver bullet to this answer, and the answer is it depends. As you may know or may not know, DC coupled battery projects have the primary use case of capturing clipped energy during the day and shifting that energy to the evening hours when the sun goes down. When we refer to clipped energy, it is the output of the solar inverters that is limited due to electrical restrictions, even though there is still additional power from the sun at any given hour available for conversion into AC power. So clipped energy is wasted energy. Overall, this type of coupling increases your yearly production, and as you know, higher production generation equates to more revenue. However, many markets or ISOs offer various revenue streams for services that may be more beneficial to have an AC coupled battery storage system, whether it's coupled with wind, solar, or standalone. These use cases range quite a bit from what we've seen in the industry the past 5 to 10 years. But generally speaking, what we've at Enertus have seen more increased use cases around frequency regulation, demand response, non-spinning reserve, spin reserve, as you can see in the ERCOT space, transmission deferral, and what we'll cover in a few slides, ramp rate control. The takeaway here is, modeling these various use cases and revenue streams with a consultant will allow you early on in your project to determine the correct inputs to your financial model. Ideally, having these various cases and scenarios to optimize your economics prior to inserting your offer into a power purchase agreement RFP or some other type of offtake agreement, or if you're dabbling into the merchant market. Modeling several scenarios and understanding your impact to returns will aid you during your internal project approval process. When you get hit with the typical questions from upper management, have you considered X, Y, and Z, and how does that impact my returns? So having these various cases in our eyes is cheap money spent, but well spent early on in the development phase. And again, just as I mentioned, reminding we're still at a stage in the project where cost of change is low and stakeholder influence is high. So let's take a quick shift to the Inflation Reduction Act. Primarily, it's really a lot of these inputs and the decisions being made are in your development phase. So a little bit of history. Pre-IRA bill, solar projects were only eligible for investment tax credit, or what we call ITC. In simplistic terms, this is a discount right off your CapEx for those buckets that are eligible year one, whether it's 30% or 26%. Post-IRA bill, solar ITCs are still around, but they've been extended for 10 years at 30%, which obviously shakes up the market when it comes to safe harbor strategy, pre-IRA bill. But they now qualify for production tax credits. So traditionally in the past, pre-IRA bill, wind projects selected the PTC route due to higher capacity factors from wind production as compared to solar. And this PTC versus ITC comparison chart, I think is interesting in relation to, the chart on the right showing the average irradiance throughout the U.S., obviously with the Southwest being much higher on net capacity factor than other parts of the U.S. So we've worked with clients to try to understand which route do I need to go, PTC, ITC route, knowing there is still guidance that the Treasury Department needs to release. But as we mentioned earlier, running these cases, multiple cases over and over with a consultant, really just gives you your bookends on sensitivities to returns and economics for your project. But I did want to take a quick step back. So if you're not aware, what are production tax credits for PTCs? So PTCs, rather than getting that year one, I call it discount or credit from your CapEx with the ITC route, PTCs allow you to claim tax credits over the first 10 years of a project, but you're essentially taking the dollar per kilowatt hour from a revenue standpoint or generation standpoint and marking that off of your taxes at the end of the year. So while you're not allowed to claim both ITC and PTC, I think between this and the standalone ITC, standalone storage ITC, there's several different scenarios, and really I think post and pre-IRA, I'm sure your financial models and project valuation teams have been running around with just updating models and waiting on Treasury Department to release some guidance. So getting a little bit back to storage though, like I mentioned, the biggest bill that a lot of us were probably waiting for the past year and a half is a standalone storage ITC. Pre-IRA bill, we were already seeing a large uptick in standalone storage projects. But as you know, investors and developers have been chomping at the bit to get this passed and have been strategizing early on with land acquisitions and development for standalone projects. But I think it will be interesting to see traditionally storage complements solar, and now we're seeing with wind very well with capturing that clipped energy and energy shifting, frequency regulation. But I think it'll be interesting to see how much more standalone storage deploys as opposed to coupling solar plus with storage. So question is, how can I stack both ITC, PTC, these other, the additional credits you can get for, depending on where your project is located? The short answer is not everything is extremely straightforward right now. I think it's a little muddy with how these credits can be stacked, what projects are grandfathered into the ITC or into the IRA bill if they were already strategizing around safe harbor pre-IRA. But the Treasury Department did release on October 5th with comments for public comment, with comments due back November 4th. So we're really expecting to see clear guidance on many of the items our clients are inquiring about or future clients within the coming months. And I'll hit on this again. So our advice, again, is plan ahead, get your modeling complete for various use cases, get those financial models built to aid you in making the right decision, pre-PPA, post-PPA. If your business case is more on the mergers and acquisitions, same type of efforts relate regardless of greenfield or M&A. So let's talk about a real project with real data, and move away from some of the theory. So this solar plus storage project, it's a confidential project with a confidential client. We'll keep this high level. It's located in the Caribbean in what we call a quote unquote microclimate. Probably sounds like a really awesome site assignment during construction. So I'm sure we'll be taking dibs on that in the Energus realm. So we're looking at on the next slide is a graph showing the blue line representing potential output in terms of megawatts from the solar resource. And the red line is your inverter output. So the gap between the two, as we were discussing before around DC coupled storage, is clipped energy or wasted energy that's not being pushed to the grid, even though there is available irradiance and generation from the sun. It's important to note though, as you see here, this is public data, it's hourly data. It's very smooth looking, little variance, not a lot of spikes. And this, typically works just fine from an OE and an IE standpoint in the US mainland, depending on the region. The next slide is the same day, but using minute interval data, thanks to an on-site MET station. So if you're not aware, a MET station or a meteorological station is a small panel that you deploy out onto the site. It contains anemometers, other instruments, temperature, wind speed, humidity, pressure. But this data gives us something much more granular in order to model the battery. As you can see, there are wild swings in solar irradiance. And as we looked over the 3 months of MET station data, it's not every day has the same type of swings. So what does this mean if you're an electric utility? You have, let's say a gigawatt of solar projects out on your grid, you're in a microclimate, you're having large cloud passes come through. This doesn't create good power quality and it causes reliability issues with the grid, right? You're trying to stick to 60 hertz, you're wanting the same megawatts throughout your peak demand. And so that's really where a battery comes into play on the AC coupling. So the use case here was smoothing out these fluctuations in the sense of how is the grid going to be viewing this at the point of interconnect. So what we did is we compared various battery durations to simulate cycle count. Should this be a half hour, a 1 hour, a 2 hour battery? And what's the most economical solution that, between us and our client can we get to well before we, engage battery suppliers and EPC? So I will give a shout out to the client. They did the right thing here. First by hiring us, it's a joke, but also serious, but also studying the use case early in the project lifecycle. Once we get engaged on a project, you get the model set up, you have your input from your field, the MET station data, running various simulations. Once you get those base cases established, it is not a large lift. And I think it's much more efficient to keep someone engaged throughout that phase of the project, preferably us, before you start making large down payments, paying fees for interconnect, for PPA securities, things like that. So this was a really interesting project, and now we're moving towards the stage of assisting the client and procuring batteries and executing the contract with an EPC on site. And I will have to give a shout out to our team member Priscilla Bell. She was the guru behind this, the brains behind doing this modeling. For both, we have several softwares that we use and also developing our own in-house battery model software. So thank her for getting us to the finish line on this one. Okay, so we've talked use case and modeling. What's next? We know our use case. We know our overbuild, our augmentation plan. What's the next step? Permitting and capacity feasibility. So identifying, depending on the county, the city, the state that you're in, what your permitting and requirements are, what environmental restrictions or setbacks, this is going to impact your project footprint and ultimately what you can fit on site. When you go through the interconnection process, right, you're identifying, I'm planning to install X megawatt AC at 4 hours, 6 hours, 8 hours, 10 hours. And this is what I need to stick through over the next 2 or 3 years of developing this project. So determining required setbacks, whether it's from environmental exclusions, noise receptors, easements, future easements, allowing space for future augmentation, NFPA 855 compliance. this will all impact your buildable acreage. And full transparency, I think we're seeing this, like, it's more sensitive, in my opinion, on standalone storage projects. You know, you're obviously not wanting to have a large transmission line for a standalone project, so you're acquiring land close to major substations, switch yards, maybe it's a retiring coal plant. So there's a lot of challenges that present within itself near these substations with overhead lines, wetlands, residential, industrial areas. So getting those established and developing what your P50 or P90 view is on buildable acreage is critical at this stage. So moving to fire safety. So fire safety and public perception of battery storage is a hot topic, and it's going to continue to be a hot topic as more battery storage gets deployed. So the table on the right, we pulled from the EPRI website. It's all public data. There's nothing proprietary here. So the table on the right lists recent incidences involving battery storage. We've worked with clients early in the project lifecycle, like as I mentioned, to provide technical support when engaging with a local fire department, planning commissions, or regulatory agencies. That really requires some technical expertise and knowledge, or what I would call, controlling the narrative for your project early on before you start, submitting permit applications, your CEQA process in California, or whether you're in New York with the TM1 and TM2 permitting requirements. As mentioned before, having a lot of this really probably be more sensitive to standalone storage with smaller spaces for building your project. We're predicting just an upward trend, obviously not only with standalone storage, but placing these projects in more complex environments, such as developments closer to city centers where there's larger nodes and load centers, environmentally challenging areas, whether you're in Alaska near a mining facility, or out in California where you're hitting 45, 50, 55 degrees C. So yeah, these complex environments are much more sensitive to setbacks where, like I mentioned, you may not have a full phase 1, phase 2 ESA, but it's working with a consultant early on to, de-risk what your views are from both a setback standpoint and buildable acreage to really target what you're able to fit on your project site. So in summary, what are the key drivers in the development phase impacting economics? One, establishing your base case assumptions on CapEx and OpEx. And whether this is pre-offtake agreement, post-offtake agreement, at some point when your exposure limit becomes, in the $5-10 million range, there's likely investment committees that you'll have to go through and get approval to your project. So you either want your returns to stay the same or go higher, right? So I think developing these base inputs, just coupled with site capacity feasibility, early battery storage modeling, what's your tax credit strategy, all couple in together to building that, what we call base case. All right, so now a test to make sure no one's sleeping. I have a battery joke, but it's discharged. So that's the joke. I'll laugh here. I'll laugh here in silence. May not get a Netflix special out of this one, but hopefully someone either spit out their coffee or laughed out loud. So now the awkward silence is out of the way. Let's go to the pre-construction phase. So as you can see from this graph, project costs is starting to rise exponentially. Stakeholder, cost of change is rising. Stakeholder influence is declining. And we're at another really critical step in the project lifecycle. So the table you're seeing here is what we're currently seeing in the industry for major equipment lead times. Obviously, how we've got here is just an increased demand for renewables, both from, in the high voltage equipment arena to containers, inverters that are pushing these lead times to the right. It's reality, and we get often asked, how can I cut my lead times? And some of that is, exploring, tier 2, tier 3 type of suppliers that may not have as much of a presence in the US, which we have assisted clients with. But I think the key piece to keep your project successful is how you're going to react to it, right? But let's get your procurement strategy in line with your pipeline, and overlap that with your project milestones. And sometimes, really, in the development phase, you're not needing a full P6 schedule, but it's just simple conversations with us and our clients, and hey, let's show the bookends on lead times for this equipment and this equipment. When do we need to cut a PO? What's my termination clause if I'm still working through PPA negotiations? All these things wrap into the procurement strategy in the pre-construction phase. So for battery storage alone, not including solar or other technologies, we've supported 2+ gigawatt hours of request for proposal or RFP support and bid evaluations for clients in this year alone. One of the common misconceptions I think some may have is you need a full 60% design package to start any type of procurement. That's not true. For much of this equipment, particularly your transformers, your breakers, between that 10 to 30% design, really, in our opinion, is sufficient to lock in material, or quote unquote your place in line from a manufacturing standpoint. When it comes to transformers, and I know we're talking about batteries, but when it comes to transformers, there are manufacturing slots, and getting your spot in line is critical early on. Obviously, some design parameters such as MVA, impedance, unload tap changer, things like that, you can tweak that as the project moves along. But coupling that with locking down supply and supply availability with battery suppliers is critical. And then we've supported clients in that RFP stage, even before a PPA is even bid, just to really get a pulse on where the market is from obviously a price standpoint, lead time, delivery schedule, what's their supply, and how does that relate with your pipeline. So that's really our ideal scope for this stage, is managing the RFP process, doing the technical bid evaluations, providing the necessary engineering support and deliverables to get you to those contracts, and then factoring lead times within the overall project schedule to set you up for success. So this slide is all about lithium. From a recent Bloomberg article, actually, I think it was only a few days ago, I really wanted to throw this in here because I thought it was a great visual for, where we're at with supply versus where we're at with the demand now that the IRA is past us. So they're projecting the additional development of up to 30 gigawatts or 110 gigawatt hours of storage between 2022 and 2023, which is just a mind-blowing amount of development, procurement, construction, engineering, coordination, financing, closing. So there's a huge goal and a huge target ahead of us. And as I mentioned before, it's just how are you going to plan ahead with your pipeline of projects? And I think we're talking about lithium here, and there's a lot of predictions of where the industry is going in terms of chemistries, technologies. But we feel the industry is moving in a direction of diversity when it comes to storage, not only with battery storage, whether it's lithium, flow, zinc, but other forms of storage as well. Hydrogen is kind of in its pilot phases, compressed air, pump storage. So each of these have their own niche on where they fit the best from an economic standpoint. But I think overall, for the industry, it's healthy to have diversity on storage. I think more diversity on the storage front will level out some of these rising prices that we're seeing, and obviously, knock on wood, hopefully continue to go down over the next 5 to 10 years. So yeah, that's kind of what we wanted to touch on the lithium piece. Okay, so there's a lot going on in this graph, a lot of inputs and assumptions that we made when we pulled this information from public sources. But one of our energy storage engineers, Andre Scordo, who has a lot of good background in operations, worked in the 24-hour control center for battery storage, pulled this data from CAISO's Oasis website over this past summer to see, how did these standalone projects fare and how did they perform in the extreme conditions and demand that CAISO was having for capacity. So while CAISO does not provide an exact detail on the cause of the forced outage, But whether it's qualitative or quantitative, you can still get to some type of conclusion, I think, from seeing some of the downtime for these storage projects. One is design your project to handle the extreme ambient conditions and site conditions throughout its useful life. And I'll hone in on its useful life. It's not what are my design conditions in year one when I COD the project, I meet my performance, it's an operational asset now. We're seeing, the useful life, as you've seen in solar projects, push from 20 to 25 to 30 to 35 years of useful life. The same goes for battery storage. Obviously, you want to have if you have a 20-year project, you do want to capture some of that merchant tail, whether it's for 5 years, 10 years, 15 years. But the climate is changing, and we need to prepare for that, especially in really some of the extreme cases in the Southwest, where you may be designing for 45C, but you may have a 15-year record high in 5 years at 50C. Is your asset going to be able to be prepared and stay online? So second, markets and ISOs are periodically or maybe constantly reevaluating how they view and dispatch storage. In traditional thermal plants, which is some of where my background came from, heat rate is king. If you have a good heat rate, you're going to be running 90-95% capacity factor throughout the summer, making money. So the same can be said for your storage project, not only from obviously round trip efficiency is key and critical, but going back to the extreme conditions, availability. Are you going to be able to respond during, let's say there's just, like in Texas or California, a nuke plant goes offline, a coal plant goes offline, these big baseload plants. How is your storage project going to be able to react and support the grid and ultimately, right, make money? So wrapping up the pre-construction phase during battery and EPC contracting, and if I haven't mentioned it before, the one piece that we see both when we're supporting a client in the pre-construction phase or afterwards, where we're brought in to, for lack of a better term, fix either a mess on site where you're trying to get to substantial completion. There's a lot of scope gaps, things like that. It's this division of responsibility, or DOR, having that established not only between your suppliers, your EPC, you as the owner, your technical consultant, your owner's engineering, looping in and understanding your PPA milestones, your interconnects, because you get to mechanical completion, you're ready to backfeed, your suppliers have everything they need, your EPC does, you as the owner do, but someone didn't, check the boxes on the interconnection milestones and submittals. Those things can really come around and bite you from getting your project to backfeed, to commissioning, to commercial operation. So that's where our opinion is, having just that third set, that independent view from a technical consultant to help you there, and just being the fresh pair of eyes and ears throughout that whole process, whether all the way from the development to mobilization stage, I think is very critical. So with supply, obviously supply availability, delivery schedule, and performance guarantees kind of all tie back into your procurement strategy and your plan. Not only what we're seeing, I think in the past, where you'd have 1 or 2 or 3 battery storage projects go through, through this process a year. A lot of clients and really as industry as a whole is just focusing more on pipeline. The projects that are signed, you have the projects that are high odds, low odds, no way it'll happen, et cetera. So starting there, I think a lot of the industry is moving further to the left on their pipeline and really trying to strategize on what they're planning on doing from a procurement standpoint. The fourth item is, fully integrated solutions, where you're getting, everything integrated between the battery manufacturer, the inverter, the EMS. There is options as well, which we've supported clients on during the RFP phase of, self-integrating. And what does that mean? It's, you're buying the DC block, the battery, you're buying the inverter, you're contracting the EMS provider. You're potentially taking two components that have not been married up to each other in terms of an integrated solution. So while there are some risks associated with that, there are benefits. And, I think if you were to engage us, we can go through that whole process, and a lot of it is the writing on the wall once you get through the RFP process, have those Q&A sessions with your suppliers and understand the pros and cons of either solution. The last piece, which is a mix between your pre-construction phase and your construction phase, is aux power. When these containers arrive on site, they need to be, in an environmentally cooled environment, depending on where your project's located. Having aux power on site, while it may be relatively low when your batteries are sitting idle, there's a lot of congestion on the distribution system in general, or no matter where you're at in the U.S. So engaging that distribution company early on to understand, hey, what load? This is the load that we need for both, idle periods or peak periods when my batteries are charging or discharging. I've seen the lead times on getting these distribution lines upgraded, conductor replaced, poles replaced, take a long time. And not only from a schedule standpoint, it's a cost standpoint as well. So this is just, as you go through that RFP process too, we use rules of thumb based on your project size. You can have those conversations as early as the development phase. And that's really what we'd recommend for most of our clients. All right, so now we're in the construction commissioning phase. Boots are on the ground, major equipment starting to arrive on site. We're moving dirt, and now you have your major milestones at the end of the tunnel. But remember, cost of changes are extremely high at this point. 10, 20, 30x compared to the development stage. Staffing levels are starting to drop towards the end of your project, and you're hopefully not at this point, not scrambling to get online, but you have weeks between your MC and your SC completion. So looking at the time, there's a lot where we're trying to fit into this webinar, and I think there's a lot more to discuss in the construction commissioning phase. But I want to leave with these three quick items, and this is going back again to the division of responsibility. So you've established the DOR in your contracting phase, but how are you going to uphold it with your suppliers, your contractors, and their agreements? Preferably, it's hiring someone like us. It's having that third party while you're focused on, engaging in IE, getting financial close, getting updates from your contractor, just having that independent view of, hey, who's actually supposed to be pulling cable from your battery to your inverter, who's responsible for installing these noise walls, who's actually talking with the transmission owner and coordinating relay protection and then things like that. So very critical. And with storage, just as with solar, the biggest piece and sometimes the most hectic piece is going from mechanical completion to substantial completion. Another piece too, and I think sometimes this is an afterthought, and I hope it gets caught more and more during the design phase, but proper labeling of equipment, right? Whether it's your battery container, is this container 1, 2, 3, 4, 5? Cables, conduits, meters, having that equipment labeled as it gets on site is really just going to serve you well during troubleshooting, during commissioning. Hope ideally, right, commissioning is smooth as butter, nothing ever goes wrong. But if you've experienced that in real life, that's not true. Things happen, but it's how you're going to respond to it by having equipment properly labeled is really going to just cut down on de-risking your delays on your project. And not only that, it's a safety issue as well. When you're doing lockout, tag out on equipment, if you're commissioning projects on a feeder by, on a feeder level, having that equipment labeled is just protects everyone. So in closing, this is how we approach storage projects. And, we're continuously capturing lessons learned through each phase, the development, pre-construction, and construction. And I think we need to be fair to, solar and wind is, in my opinion, in our opinion, much more established in the space as compared to battery storage. I think we're getting there. In the past 3 to 5 to 6 years, storage deployment has just exponentially ramped up. And I think there's just, capturing those lessons learned. We're constantly giving feedback with clients of what we've seen on other projects, whether it's with supplier X, Y, or Z. And so really this, us being a third party, we're agnostic to technology, but our broad experience in the solar and storage space, whether we're acting as the owner's engineer, the independent engineer, et cetera, really just serves our clients in the end for project success. So yeah, with that, I hope you enjoyed my presentation. I know we put a lot here in 40 minutes or 30 to 40 minutes, and I'm sure there's probably some questions in the Q&A log, but we'll leave it open to that. So yeah, Stephanie and Jeff, if you guys want to come off mute, we can start tackling some of the questions.
Yeah, great. This is Jeff. So a couple of questions have jumped up, and I guess the first, and so we'll run through these. The first couple might be here a little related, but how can developers economically analyze multiple storage technologies, chemistries to assess which would be optimal to couple with renewable energy project?
Yeah, so it's great question. And as we kind of touched on a little bit through in the development and pre-construction phase, we're agnostic to all technologies, and we want to be the fiduciary for our client and suggesting to them what makes the most sense from a chemistry standpoint, duration, supplier credibility, based on the specific project use case, environmental conditions. If a client has projects all over the U.S. At various interconnection voltages, use cases, there may not be one storage solution that fits all of these, right? And that'll tie back to your procurement strategy and of how you bucket those types of projects together. So yeah, I think our experience is pretty vast on the topic of chemistries and integrators in the storage space.
Right. Is there a simulation software for battery systems equivalent to PVsyst?
Yes, there is. So primarily, what we use for a lot of our independent engineering battery simulation is a program called Homer. It's a program developed by UL. It's a great program for a variety of use cases. But what we've actually kind of started exploring more often is, we have a lot of really smart programmers in our data science group. A lot of it's the MATLAB and the Python coding, taking the use case from your PPA and then putting that into Homer. So I'll give you a small sneak peek. So we are developing more of our own in-house type of post-processing tool once we take those PVsyst inputs for a coupled project to be able to more efficiently and quicker turnaround times on the battery modeling piece, primarily using MATLAB and Python.
Okay, great. A few more. So does Energy have experience advising clients on energy storage solutions other than lithium ion?
Yes, short answer is yes. We've engaged, I may not be able to name drop them here on this presentation, but we are engaged as OE for a few non-lithium battery suppliers as they start, developing pilot projects and engaging with customers. So really, I think this kind of ties back into our QA/QC department as well. Is if there is a new chemistry, a new supplier out there, we're having clients now engage us, say, hey, while they may have already some type of bankability report from another consultant, they really just want boots on the ground in the factory to understand the quality process, all the way from factory FAT to real life deployment. So yeah.
Great. Another question is how does this all relate to an investor that's looking to acquire late stage development project or operating storage assets?
Good question. So I think, in general, the approach is relatively the same, whether it's greenfield, M&A. I think with our experience as both an OE and an independent engineer, or often referred to as an investor engineer, we're experienced identifying key risk items throughout each project phase, And whether we're coming into a project in the pre-construction phase, where the developer is acquiring a site that's late stage, maybe materials secure, nothing's arrived on site, but you still go back to that development stage and ask the same questions, right? You're essentially buying the development rights to a project with a PPA and not an interconnect agreement, but you still go back there in the the very beginning. Okay, what was the use case? How did you model this? What's the engagement been with the local community on this project because it's located next to a school or a large neighborhood? So, in summary, I think just our ability to have the view from an OE and an IE, whether it's greenfield or M&A, is definitely beneficial to our clients.
Right, great. Do you have a sense of what are kind of the current warranties or standards for battery offered by the battery providers?
It's a bit of a loaded question, and I think we probably could follow up in more detail if whoever asked this question wanted to reach out. So going back to the fully integrated solution versus self-integrating, the typical, whether it's just with a tier one integrator, typical PPA, right, is 20 years, and that's typically what we see when you sign a limited term service agreement to guarantee that energy capacity over the 20 years. And really what that comes with, right, is that supplier is taking responsibility for guaranteeing X megawatts and X megawatt hours at your point of interconnect throughout the term of your project. And that's, that gets coupled with initial overbuild, augmentation strategy where you're having to make those payments in year 4, year 5, year 10, et cetera. So there's a variety of different approaches to the warranty piece, both from a, workmanship or, strictly equipment standpoint, but also, energy capacity. So yeah, I think that's the short answer. And I think the long answer is, reach out to us. And I think further understanding what your project is, what your target PPA term is, and, the use case, I think would probably serve a little bit more detail. So.
Okay, great. And man, I'm not sure if this is you or who, but one question was, does Enertus consult on hedging contracts or other revenue models?
Little confused on what the context of the question is, but I'll take a stab at it. So revenue models, right? We obviously, most of the information, right, is public in terms of revenue streams, depending if you're an ISO, CAISO, ERCOT. The one piece, and this may be related to merchant, hopefully, maybe not. We're not in the business of, predicting LNP prices at nodes. We don't have that software in-house, but what we've also often done with clients during that merchant period, whether the project's fully merchant, they're trying to look at the merchant tail on the project, is take those inputs from another third-party consultant and run that through our battery modeling software to to understand this is a really aggressive merchant period with high LNP prices, which is resulting in 1 or 2 or 3 cycles a day for your storage project. How does that relate to augmentation and my overall CapEx and OpEx? So yeah, I mean, I think it's an interesting question on hedging contracts and revenue models. I'd encourage whoever ever asked that, just shoot us a note. Would be happy to get a little more context on your question.
Great. A few more that we'll jump to here. One is that scale seems to be an important factor in BESS economics and returns. Do you have a sense of what the lower bound is on capacity for standalone solutions that are getting done with institutional financings?
Ooh, good question.
Pretty specific, but
yeah, good question. So scale, I agree. Obviously we have clients and projects that we've worked on that are, in the 1,200 gigawatt or 1,200 megawatt hour range, all the way down to 2 or 3 megawatt hours for, more of a behind the meter or CNI type of project. And I agree, a lot of your top 3, suppliers or integrators in the industry are looking for those big, 1, 2, 3, 4 GWh scale type of portfolios and deals. But that doesn't mean that there are not other integrators out there that can support, lower volume. And we're actually just got engaged with a client with, an integrator personally I have not heard of. They are using tier 1 cells, but they're targeting that more C&I type of customer. And I think that's going to be, it's a smart hedge if you're a supplier to, have that diversity on who your target customer is. So yeah, that kind of tying back into the QA/QC piece too is when you're going for that financing phase with whether it's tax equity, debt financing, what have you. That bank is going to want to see, hey, we've never heard of this integrator. We need someone as an IE such as Enertus to not only comment on it from a desktop standpoint, but do a factory visit, understand how their EMS works, their BMS, and check all those boxes in terms of signing off that they're a credible supplier when you get to the financing piece.
Yep, great. A couple kind of operational questions. Once operational, what poses the biggest operational and technological risk in your view, and what types of reserves should a lender be thinking about to protect against future issues like that?
Great question. I may give a kind of a circular answer in a sense. Going back to, we had that slide up about some of the battery performance out in CAISO this summer. And obviously we hid the names of the projects, I think it was fair that way. So I always like to think of how can I prevent operational and technological risk before COD, right? I think that that helps de-risk what's going to happen afterwards. And two big things, right, is designing your projects to handle any type of ambient conditions from a temperature, dust, if it's near a coal plant, things like that. Year 1 throughout the useful life is key. 2 is future augmentation. This is always a tricky subject because year 1, I'm installing LFP batteries. I have 400 MWh, and I'm planning to augment in year 5. Well, what is the battery going to look like in year 5? Most of us have a somewhat of an educated guess, but a little bit of it is a guessing game, right? It's chemistry is planning to change. Hopefully pricing gets cheaper, more dense. So I think not only from a physical space standpoint, but, just having the adequate, spare conduits and, planning ahead for some of those augmentation periods and monitoring battery performance over before you get to that augmentation piece. I think really just that O&M and asset management from a de-risking standpoint really is key. And we've already seen some clients reach out both on the PV and solar side and say, hey, I have 10 projects. They're all operating, but I'm not happy with performance. And maybe we need to augment here soon, but can you guys do an independent view of performance as it relates to our contract? So great question though, and would be happy to chat about it further and just kind of go back and forth. And I know we have 7 minutes left, but hopefully that answers your question.
Thanks. And kind of a related issue, there's a few questions on fire incidents specifically, and what kind of steps can be taken during that earlier stage development or even later to sort of address the issue with the community and also just kind of protect against it. Do you have any sort of specific thoughts on fire incidents?
So, we're now at a stage in the industry where if you're using a tier 1 cell supplier, most if not all should have their UL 9540A certification, which if you're not familiar with that, it's certifying that there's not module to module propagation in the event of some type of fire. A specific project I worked on years ago in Georgia, we were deploying or attempting to permit a very large battery storage project. Frankly, in a county, there's a lot of residential nearby, and they were not familiar with battery storage, right? A lot of counties and states have ordinances and steps to get your battery storage, specific to battery storage to get it permitted. So those are nice in the sense they have, a lot of checks in the box that you need to get through, to get that, through the planning commission. But what we ended up doing is, back when I was on the development side, we engaged with both an owner's engineer, to help us with some preliminary layouts, kind of back into that development phase. But we also hired, just pick their brain from a fire protection standpoint of explaining what is UL 9540A, what's going to happen if a container does catch on fire, what's our mitigation plan. So I think, heck, even meeting the HJ or the local fire department on site and just having that face-to-face communication early on allows you to control the narrative. And using the term controlling the narrative is not you're trying to slide through the permitting process. It's just building that relationship, right? You're an investor in the community from a proper, ad valorem tax standpoint. So you want them to be comfortable with your project and support it, not only through the permitting phase, but throughout the useful life. So kind of just wrapping up the answer, I think engaging with the technical consultants such as us, keep, inviting us to have those conversations with the local community, either at town halls or with the fire department, I think is key to get through that process before you get to the pre-construction phase.
Right, thanks. And here's a question that it might be more legal in nature, but we've seen tariff protection and ESG requirements become an issue or kind of applied on the module side. Do you kind of see or anticipate that becoming an issue at all on the battery side?
I probably don't want to make any type of prediction live here. I think what's again, kind of going back to what's healthy for the industry, and obviously with the IRA bill, and recently I just saw there was another bill funding, more domestic battery manufacturing. I think that's the right step to have that diversity. We're seeing it in the module space as well. And a lot of developers, pledging by 2030, 2035 that X% of their projects will be using domestically produced materials. And it's not to say that we would completely shy away from materials that come from overseas, but I think I think diversity is good at this point, and healthy and competitive for the industry. But to the original question, do we anticipate future tariffs that we're seeing on module batteries? I'm not sure. I think it was probably more of a legal question, or Jeff, if you have any insight on that as well, we could always have a side conversation with the person who asked the question.
Yep. Yeah, it is interesting because it certainly could be an issue. The battery space is a little more interesting in that regard, in that there's been a long history in the automotive space with batteries. And so it's not just a battle that the solar industry or renewables would be having, but that would cause a much larger issue in the space, in that front. The other thing we kind of chatted before the webinar, but we're actually seeing for the first time, probably in the solar kind of industry, but a much bigger movement of manufacturing facilities, domestically or into North America. And I think that's a trend. I've got 4 of those we're looking at right now, and that's a trend that we'll probably see more and more of. Maybe one last question or so, and then there's still a handful that I know we can kind of answer those offline as well. Battery storage is obviously the hot topic right now in the industry for storage. The comment is that compressed air storage seems like it has a longer history and maybe even some other advantages, and but hasn't seemed to really kind of take root in renewables. Do you have any thoughts on compressed air storage versus battery, or any other kind of technology that might be promising?
Yeah, I mean, I think having my nuclear and fossil background, and I think compressed storage is super interesting. I've had some experience as well with pump storage, but obviously the two, you can't deploy them everywhere, right? You can't, go build a mountain to have a pump storage facility in the middle of the desert. So I think geographically, it just depends on where, where those projects could be deployed, where's the nearest transmission line or load source. But yeah, no, again, kind of going back to, even a company like Energy Vault, coming out with that type of technology, I think it's good to have competition in the space, whether it's lithium, flow, long duration, compressed air. So yeah, I really at this point support any type of, or follow any type of pilot project for different solutions. And some will take off, some may just have their own niche in the market. But I did talk with an old colleague that they're primarily in the pump storage business, but they're even looking at, hey, let's find ways to use batteries, whether it's lithium or non-lithium, for some of these type of frequency regulations, because trying to have a variable speed pump storage system is a pretty violent process with how much water you're pumping and just how big the equipment is. So I can see too, a lot of these technologies starting to complement each other, whether you're with compressed storage and you have lithium on site, or pump storage with lithium on site. So definitely exciting times.
Great, thanks. And with that, I think we're at the top of the hour. I see we're probably starting to lose some folks, and there's a handful of other kind of very specific questions that might be best to just take offline. You can answer them directly. So with that, I'll turn it back, I think, to Stephanie to wrap things up.
Sounds good. Yeah. Thank you, Matt. Thank you, Jeff, and appreciate everyone's comments and great questions. Our contact information is on the screen right there. So please don't hesitate to reach out, and we'll be happy to get on a phone call or email, answer things as best we can. But yeah, we look forward to having you join our next webinar, likely the beginning of the new year. Appreciate your time and hope everyone's successful in all their projects. Thank you.
Yep. You guys take care.